Welcome back, PrepStation SSCE Tutorial Physics, Lesson 4. And under Lesson 4, we want to look at projectile motion. We just discussed linear motion. I told you the topic motion is actually very broad. So let's look at projectile motion. And under projectile motion, we are going to consider just 3 projectile motion. What is it all about? And then number 2, components of projectile motion. Then number 3, equations of projectile motion. Mind you, when I say equation of projectile motion, I'm not talking about new equations. I'm talking about the modification of the 4 equations of motion I gave you. I'm only going to modify those equations because of what? Acceleration due to gravity. Not to worry, I will explain when we get there. So let's quickly move forward. What do we have here? Projectile motion. A projectile motion is the motion of an object thrown into the air. You know, you are only responsible for the object going into the air, but how the object maneuver through the air is not your business. For example, if I throw this pen up, I'm only responsible for the upward movement. I'm not responsible for the downward movement. The downward movement is being taken over by what? Force of gravity. Okay, so projectile motion is any object that travels with the influence of what? Gravity. Maybe horizontal projection, vertical projection, or angular projection. Okay, so long as it has to do with gravity, you call it projectile. For example, look at this young man kicking a football here. Okay, let's assume that this is Ronaldo trying to score a free kick. They actually use projectile in scoring free kick. And this is why I keep telling students that physics applies to everything we do every day. Look at physics in football. Okay, so let's see what happened next. Projectile motion. Yes, projectile motion is a 2 independent, one-dimensional motion. One horizontal and the other vertical. By the way, projectile motion is a 2D motion, 2-dimensional. But when it comes to resolving it or solving it, you split it into 2 and then deal with it as one-dimensional, 1 dimension for X, 1 dimension for Y. For example, this is a cannonball. If you release the cannonball from this height, what do you expect? Do you think the cannonball will move horizontally and fall vertically? No. The cannonball is going to move in 2 dimensions at the same time. At every point of this motion, the cannonball is actually moving horizontally and vertically. And it's going to take a parabolic path because of the 2-dimensional movement. Okay, so that is that. So let's look at one more thing. The motion consists of what? The vertical component that is affected by gravity and the horizontal component that is affected only by air resistance. Only by air resistance. So the horizontal component has no business with gravity. It is only the vertical component that is affected by gravity. Okay, now each of these components of motion have specific characteristics that can be taken advantage of to solve problems. That is it. When you are solving problem in projectile, always have it in mind, you are dealing with 2 dimensions. One is horizontal, one is vertical. Then have it in mind, vertical always affected by gravity. Horizontal has nothing to do with gravity. Okay, if you have that in mind, then you have solved your problem out with vertical component. In the vertical direction, projectile accelerate or decelerate, due to the force of gravity. So the vertical acceleration is called AV. A subscript V means vertical acceleration of any projectile is always 9.8. Now, what is 9.8? 9.8 is acceleration due to gravity on this side of the planet. Okay? Though some places you have 9.9, some places you have 10, but here we have 9.8. And then horizontal component, the acceleration, A subscript H means horizontal component of acceleration, is always 0 because the force of gravity only acts on the vertical component. With this pen in my hand, okay, if I move this pen to the edge of my finger, it will definitely fall. I'm not responsible for the fall. This is called free fall, gravity. Okay, so I'm not responsible for the gravity, but the horizontal component, if I push this pen this way, that's the horizontal component, I may be responsible for the horizontal, but not for the vertical component. So the acceleration in horizontal component is 0. Why? Because horizontal component velocity does not change. It remains the same throughout the motion. And then by definition of acceleration, acceleration is simply the rate of change of velocity. So if velocity in horizontal component is not changing, therefore means there is no acceleration. Okay, I hope that makes sense to you. So let's quickly move forward. In solving projectile problem, we consider the following. Yes, what will you consider? Nigeria curriculum has made it so easy with a standardized formula where you don't have to stress yourself deriving the formula. So we just go straight to it. So in Nigerian curriculum, we have three parameters to actually look at. Three parameters, that is for WAEC. We have what is called the time of flight. Although before you get to time of flight, you have to consider time taken to reach maximum height. If I throw this pen up, I can calculate the time it takes to reach maximum height before it starts coming back to the ground level. And then we have time of flight. Time of flight is the total time spent by the projectile in air. If I throw this into air, so the time it takes to go up and then come down is called time of flight. Then we have maximum height reach. If you throw this pen, the maximum height is going to reach before coming down can be calculated. Then we have the range. The range has to do with the horizontal. If I throw this pen horizontally, the distance is going to cover this range. So that means in projectile motion, we have two distances to consider. Number one is called vertical distance. The vertical distance covered by a projectile is called height, while the horizontal distance covered by a projectile is called range. Then we have what is called the maximum range. When do you consider range as being maximum? It depends on the angle of projection. Once the angle of projection is 45 degrees, then you have arrived at what is called maximum range. And this is the technique used by the military in firing missile, which I'm going to show you later. Now, these equations can be derived using the four basic, look at that now, the four basic motion equation. I told you anything related to motion, whatever I'm going to do, I will still depend on that four basic equations of motion. Now, look, this is it, the four basic equations of motion. In case you have forgotten, let me remind you once again. So everything I'm going to do for projectile motion will depend on these four equations of motion. Now, note, before using this equation, the velocity of a projectile must be broken down into what? Components. Why? Because projectile motion is a 2D motion. 2D of what? Horizontal components and vertical components. All right, let's quickly move. Now, time of flight. Let's start with the first parameter. I gave you three parameters. Number one, time of flight. Number two, maximum height. And then number three, range. Okay? Now, what is time of flight? At maximum height, the final velocity V of a projectile is 0. What does that mean? If I throw this pen up, I'm only responsible for the upward movement. Now, this pen will continue to travel until it gets to a point where the final velocity is 0. And then at that point, what happens? It starts coming down again. Now, why is it coming down? At that point, I'm not responsible for the downward movement, but gravity takes over from there. So at maximum height, final velocity is 0, while acceleration due to gravity acts negatively. Another point to consider. When an object is going up, force of gravity or acceleration due to gravity acts on it negatively. But when an object is coming down, acceleration due to gravity is considered positive. Okay? All right, so now recall, what are we recalling? V equals to U plus AT, the first equation of motion. Also, the horizontal and vertical component of the velocities are UX, okay, V cos theta, and then UI, V sin theta. What does this mean? Now, this particular V that was given in linear motion, if I'm dealing with projectile, I have to break them down into two. One in the x direction will be V cos theta. I don't want to go into the derivation, there is no time for that. And then one in the y component will be V sin theta. I will explain that as we progress. Okay, then what else? Now, 0 equals to uy minus gt. Now, where is this formula coming from? Let me quickly show you that. Remember the first equation of motion, V equals to u plus at. Now, I told you for projectile, all I need to do is to modify the equation. So the modification here is this. At maximum height, final velocity for projectile is 0. That is why V has translated to 0. Now, initial velocity for projectile, the reason why we have it y, we are trying to say that the velocity you are looking at right now is for the y component. If it is for x component, I will put x here. Now, why is this one g? A is acceleration due to gravity. So for projectile, A will change to g. I told you when an object is going up, g is considered negative. When an object is coming down, G is considered positive. So for this object going up, A will change to G and G will be negative. So that is why we have this formula. This is a modification of the first equation of motion. I believe that makes sense to you, and that is all I will do with every other equation. So with this, if you make T the subject of the formula, if you make T the subject of the formula, T will be equals to Uy over G. But Uy equals to U sine theta. So U sine theta over G, this is the first equation for projectile motion when you are calculating what? The time taken to reach maximum height. Now, the time of flight is twice the time taken to reach maximum height. What does that mean? If I throw this pen up, if it takes 1 second for this pen to get to maximum height, it will take the same 1 second for this pen to come down. So that means time of flight is equals to 2 times the time taken to reach maximum height. So with that understanding, all I need to do to get time of flight is to multiply small t by 2. And then small t equals to U sine theta. So that means big T equals to 2U sine theta over T. I believe that was simple enough. So this is the time, the formula for calculating time of flight in projectile. All right, let's look at another one. Maximum height. Now, this is the total vertical distance. Remember I told you in projectile motion, 2 distances are involved. The vertical distance called height, the horizontal distance called range. So for maximum height, this is the total vertical distance covered by a projectile where the final velocity is 0. Why is final velocity 0? Because as the object continues to go up, force of gravity is acting on it negatively. If not for force of gravity, this object will continue until space. Okay, so final velocity will be 0 because of the influence of gravity. Now recall, what are you recalling? This formula. Do you remember this formula? Do you remember this formula? Let me quickly show you. This formula is coming from V squared is equal to U squared plus 2AS. So the modification here is that this is T Uy squared. Now because the object is going up, this will be minus 2, A will change to G, and then S for distance will change to height, because vertical distance covered by a projectile is height. Do you get that now? Okay, so let's move forward. So V squared equals to this formula. If you modify this formula, then you get all of this. And then if you continue the modification, S will be denoted as H, and then this will leave us with this formula. So this is the formula for calculating the maximum height covered by a projectile. All right, let's look at another parameter under projectile motion, and that is range. Now, I told you range is what? The horizontal distance covered by a projectile. Now, this is the total horizontal distance covered by a projectile where the velocity is constant. Remember, I told you that. And because the velocity is constant, the acceleration will be 0. Now, recall this. This is another equation of motion, and this is coming from equation what now? This should be equation 4. Now, remember, acceleration for horizontal component is 0. So if acceleration is 0, what will happen? By the time you put acceleration 0 here, what happened to the whole of this value? The whole of this value will disappear, leaving you with ut. Okay, leaving you with ut. So that means S will now be equal to R, and then it will be equals to what? Uxte. Why do we have it this way? Because the whole of this has vanished to 0. Because why? Acceleration is 0. Now, this is distance, but because we are referring to horizontal distance, we change S to R, range. And then because we are dealing with horizontal means x-axis, we change U to X instead of Uy, like the other cases. So this is the formula for calculating range. I believe that makes sense. So if you continue with this formula, you end up with 2U sine theta over G as the formula for calculating range. I want to believe you have seen all of this formula before. I'm only trying to derive, okay, how this formula, to show you how these formulas were derived, okay? Then what next? The last one is called the maximum range. The maximum range is just a modification of the last formula I just gave you now. And that happens when the angle of projection is 45 degrees. If the angle of projection is 45 degrees, then you get this. Now, how did this formula change to this? Remember, range is equal to U squared sine 2 theta over G. So in a situation where theta is 45, what will happen? Then you have U squared sine 2 times 45 into bracket over g. So what happened next? U squared. 2 times 45 is 90 and sine 90 is 1. So the whole of this will go and become 1. And anything multiplied by 1 is still that value. So this will now leave me with u squared over g. So this is how this formula graduated to this y, because the angle of projection is 45 degrees, okay? So now that we have considered all of these equations, let's quickly look at some wire questions related to this. Is that okay? All right, so let's quickly look at question number 1, 1994, question 4. An object is projected with a velocity of 80 meters per second at an angle of 30 to the horizontal. The maximum height reached is what? Okay, now let's get all the parameters. The answer is 80 meters. Don't panic, I will show you how we got this answer. All right, so here we have the parameter. Theta was given as 30, initial velocity as 80. We are looking for height. Now don't forget, this is a two-dimensional motion. So what will I do? Break the velocity into two of x and y. And how do you do that? Now this is the formula, remember this formula for maximum height, okay? So if you remember that formula, what next? Substitute a value. That was why I told you in WAEC curriculum, projectile questions are actually very simple, because you have an already made formula where you just have to slot in the value and solve your problem. So this is the formula. All I need to do is slot in this value into the formula, use your calculator to play with the numbers, and what happened? The answer will come out as 80 meters. This should be 80 meters. Sorry for the end there. That should be 80 meters. So option B is the correct answer. Let's quickly run. A missile is projected so as to attain its maximum range. Calculate the maximum height attained if the initial velocity of projection is 200. Okay, so what should we do? Let's go quickly to the answer. Parameter given. Now, this angle was not given, but how do you know that the angle is 45? Let's go back. Because from the question we were told, look at this, maximum range. And I told you when I was deriving the formula that maximum range is attained when the angle of projection is what? 45. So for mentioning maximum range, that alone gives me the idea that the angle of projection is what? 45. Now, what is the formula for maximum range? Projectile is actually very simple, okay? Very simple, okay? For height, I mean. So for height, this is the formula, u square sine square theta over 2g. So substitute what you have here into the formula. So simple. Where you have u, put 200, yes. Sine squared. Where you have theta, put 45. Then g is 10. Play with this again using your calculator. The answer will give you 1,000 meter. Again, sorry for this. The unit is meter. 1,000 meter. Let's quickly run. A stone Q is thrown with a velocity of u at an angle of 75 to the horizontal. Another stone R is thrown with the same velocity but at an angle of 15 to the horizontal. The range is covered by the stone will be what? What will be the answer? Okay, the range is covered will be the same. Do I need to explain this? There's no much explanation. Do you know why? I told you at the beginning of this very slide that the vertical component of the velocity of the motion does not depend on velocity. It's only gravity that is responsible. So whether this stone was projected at 15 degrees or whether it was projected at 75, it doesn't matter, because you are not responsible for the vertical motion of that. So the answer will be the same. In projectile motion, horizontal velocity determines the range and at the same time remains constant. So the answer is the same for both, since they have the same velocity. Okay, so that does not determine anything. This one is just a test of your knowledge of all the formulas that I gave you. A ball is thrown vertically into the air with an initial velocity of u. What is the greatest height reached? What is the greatest height? Now go back to your projectile formula. H equals to what? U squared over 2g. U squared over 2g. So the correct answer is u squared is this one. U squared over 2g. Okay, that is the correct answer. Two bodies x and y are projected on the same horizontal plane with the same initial speed but at an angle of 60 and 30 respectively. Neglecting air resistance, the ratio of the range of x to that of y. Now this is completely out of physics, even though we are going to use physics principle to relate it, but you need good knowledge of mathematics to be able to solve this. Okay, this is just linear equation. Now, why is this so? Let me quickly show you. This is a little bit different from what we have done so far. Now, this is the formula, u squared sine squared theta. Now, since u and r are constant, remove them. That is what you do. Since u and r are constant, remove them. So what do? Simply play with the formula. U and r are constant, so remove u and r. That will leave you with u squared over g. Why? Look at it. U and r, u squared over g. So from here, you are now relating the ranges for the two objects. This is outside the formula of projectile now. You are just using your normal knowledge of mathematics to work on this. You know, numbers were not given, only angle. So by the time you play with this, R1 over R2 equals to sine 2 theta 1 over sine 2 theta 2. And then what happened? Now, theta 1 was 30. So 2 times 30 is 60. Theta 2 was 60. 2 times 60 is 120. And by calculation of trigonometry, sine 30 is root 3 over 2 divided by sine 120 is also root 3 over 2. And by the law of fraction, if the numerator and the denominator is the same, what do? You just cancel out. So this will leave you with 1 over 1. Therefore, the answer to this question is ratio 1:1, which the option is A. All right, so let's quickly move. Question number 6. A shooter wants to fire a bullet in such a way that its horizontal range is equal to the 3 times its maximum height. Yes, another tricky question, which of course you will start with physics principle but end up in mathematical principle. The answer is 53, but let's see how they got 53. Let's see quickly. Now, all these values were not given. That's why it's a very tricky question. All these values were not given. They only told us that the range is 3 times the height. So this is a kind of word problem. They're using the disguise of projectile, but notwithstanding, we are still going to find a way out. Now, what is the formula for range and what is the formula for height? Okay, so the formula for maximum height is u squared sine 2. Sorry, the formula for range is u squared sine 2 theta over g. The formula for maximum height is u squared sine squared theta over 2g. This 3 is because of the question. The question says range equals to 3 times the height. So all I need to do, bring the formula for range, bring the formula for maximum height with the 3 attached to it, and then work on this question as if you are just dealing with normal mathematical expression. Now, if you do that, it's going to leave you with sine 2 theta and then equals to 3 over 2 sine squared theta. Do I need to go through this? Okay, let me quickly show you something here. Now, what happened is u squared will cancel u squared. Can you see that? G will cancel g. So what do you have left here? You have sine 2 theta left here, which is this. And then on this side, you have 3 over 2 sine squared theta. So do you understand how we got to this point now? Now, from here, we are going to apply the trigonometric identity. And what is that identity? The identity says sine 2 theta is the same thing as 2 sine theta cos theta. So in the place of sine 2 theta, I'm going to replace it with 2 sine theta cos theta. So if you do that and continue playing with this number, you are going to end up with sine theta over cos theta. And according to trigonometric identity, sine theta over cos theta is the same thing as sine theta. You need a good foundation of mathematics to be able to solve this. But notwithstanding, since it was included in physics question, we just have to solve it, okay? So sine theta over cos theta equals to tan theta, and then tan theta, inverse of tan theta, which is 4 over 3, will now give us the answer as 53 degrees, okay? So just take your time and go through this again. You will understand how it is solved. Now, number 7, a bullet fired vertically upward from a gun held 2.0 meter above the ground reaches its maximum height in 4.0 seconds. Calculate its initial velocity. Another nice question. I think this one is projectile question. Now, let's see how did they get the answer. This is WAEC 2009. The parameter given, we're given acceleration due to gravity 10 meters per second squared. We're also given the time 4 seconds. And then we're given final velocity 0. Why? I will tell you again. At maximum height, the final velocity for a projectile is what? 0. Okay? Does that make sense to you? Now, where is this formula coming from? The first equation of motion, V equals to U plus AT. Modify. Why are we modifying it? Because this is projectile. Now, at maximum height, this is U. Now, the object is going up. So A will change to acceleration due to gravity. When an object is going up, G is negative, so the all of this changes to GT. Nothing has changed. So if you continue from there and make U the subject of the formula, knowing that this is 0, then you'll be left with U equals to GT. What was G? 10. What was T? 4. So when you play with this 10 times 4, you have 40 meters per second as your final answer. Does that make sense to you? Very simple question, right? We have 3 more to go. Now, a projectile is fired from the ground level with a velocity of 300 meters per second at an angle of 30 degrees to the horizontal. Calculate the time taken to reach the maximum height. So what we are calculating here is small t, not big T. Time taken to reach maximum height. So as usual, okay, I think this has moved a little. It's supposed to be 15 seconds here. It has moved due to adjustment. So let's see the parameters on ground. We have theta 30, we have initial velocity 300, and then we are looking for the time. We are looking for the time. So how do you solve for time? Yes, this is the formula for calculating time taken to reach maximum height. U sine theta over G. So what do? Substitute the values. Oh my God, substitute the values. So you have U sine theta over G. So substitute the values, play with the numbers. Then you have your answer as 15 seconds. All right, 2 more questions to go. We can do this. Don't be tired. We can do this. Now, during a football match, a player kicked the football at an angle of 30 degrees to the horizontal with an initial velocity of 30 meters per second. Calculate the maximum height. This has to do with maximum height, okay? So what will be the answer? The answer is 11.25. Don't bother. I'll show you what to do. So 11.25. So let's go as usual, get the parameters. What are the parameters? We have angle 30, we have velocity 30, we have height question mark. What is the formula for calculating maximum height? It's simple. U squared sine squared theta over 2G. That's the formula. So what do you do next? Substitute all this value into these, substitute the values into these, and when you do, use your calculator to play with the numbers, then the answer will give you 11.25 meter. Option C. And then lastly, in this session, a body is projected at an angle of 30 to the horizontal with a velocity of 150. Calculate the time it takes to reach the greatest height. Again, we are looking for time taken to reach maximum height. Okay, this one is an essay question, so don't panic. It's still the same method I'm going to use. This was given theta 30, initial velocity 150. We are looking for t. Again, this is the formula. You see why this topic is very simple, because you already have a formula ready to be used. All you need to do, identify the formula, substitute the values, and then play with the numbers, okay? So from here, what do we have? Substitute the values. What were the values? Theta is 30. So where you have theta, put 30. And then U is 150. Where you have U, put 150. Sine 30 is 0.5. 0.5 is half. And then half times 150, that is 75. 75 divided by 10, that is 7.5. So the answer is 7.5 seconds. So guys, with this, we have come to the end of lesson 4. Watch out for lesson 5.